All right, let's put this into action with example 2. So example 2, we are going to use Newton's method to estimate the square root of 5 by finding one of the zeros of x squared minus 5. So let's just get a graph of this. Not that we need it, but sometimes the graph can give us a little bit more of an intuition before we start working with things. So here's our graph, and our parabola does something like this. Okay, this is -5 right here. So that means these values are negative root 5, and this is positive root 5. Okay. So we can start anywhere we want to. Notice that 2 is somewhere right in here. All right, so this is let's go ahead and say that this is 2. So let's go ahead and use x naught equals 2 for our first guess in this process, our first value. So let x naught equal 2. Then we have f prime of x equals 2x. So x sub n plus 1 is equal to x sub n minus f prime of x sub n, or not f prime, excuse me, f of x sub n, all over f prime of x sub n, which is x sub n minus x sub n squared minus 5 all over 2x sub n. Okay. Now sometimes this expression that you get here, sometimes simplifying it might make your life easier in calculating these things. It honestly doesn't matter to me if you want to choose to try to manipulate this to make it easier to work with. When I did this previously in my typed notes, I went ahead and modified this a little bit because I felt like it was a little bit easier to work with when I was doing this by hand. Okay, so that doesn't matter a ton. Let's just go ahead and do the process. So we're going to go ahead and find x sub 1. So we're starting with x0 equals 2, and then x1 is going to be, well, it's going to be 2 minus, we're going to have x squared, so 2 squared minus 5 all over 2 times 2. And it just so happens that this is equal to 9/4, which as a decimal is 2.25. So then our next x value, x2, will come from plugging in 2.25 instead of plugging in 2. So this will be 2.25 minus 2.25 squared minus 5 all over 2 times 2.25. This turns out to be 161/72, which, if we round this to 5 decimal places, is 2.2361. Similarly, we're now going to go ahead and take this value as our next input. So I'm not going to go ahead and write this number out each and every time. It's a lot to write out. I'll do it anyway. Okay, we'll just do it this time. 2.2361 minus 2.2361 squared minus 5 all over 2 times 2.2361. This, as a fraction, is 51,841 all over 23,184, which, as a decimal, rounded to, again, 5 decimal places, is 2.23607. And then you get the idea. We just keep going. So this would be 2.23607 minus 2.23607 squared minus 5 all over 2 times 2.23607. This, as a fraction, is ridiculous. I'm not even going to write it for you. I'm just going to go ahead and say ridiculous. And then this is approximately equal to 2.2367. So even after one additional iteration, when you're rounding to only 5 decimal places, none of these changed. So if any changes did occur, which there would have been changes that occurred, they must have occurred something that wasn't enough to round this 7 up any higher. So sometimes a problem might ask you to estimate a certain value, such as the square root of 5, estimate it to 5 decimal places using Newton's method. That means you're going to want to continue this process, and then you're going to want to keep track of the first 5 decimal places, and you're going to keep going until, from one iteration to the next, those 5 places do not change. And then that would be your 5 decimal place estimate for the square root of 5. So we'll just conclude here. Therefore, the square root of 5 is approximately 2.23607.